Hi everyone, welcome to our webinar today, How AWS Data Exchange Can Answer Tough Questions. I'm Caitlin Swartwood and I work on Startups Business Development for AWS Data Exchange, and I'm joined by Natasha Chernikina, one of our software development managers also dedicated to AWS Data Exchange. AWS Data Exchange is a service that makes it easy to find, subscribe to, and use third-party data in the cloud. Data scientists, data analysts, and developers in nearly every industry use AWS Data Exchange for access to third-party data to drive analytics, train machine learning models, and make data-driven decisions. These are our beautiful photos here. Natasha, want to go ahead and introduce yourself and tell us a bit more about what your team builds?
Of course. Hi everyone. My name is Natasha Chernikina, and my team is responsible for the AWS Data Exchange core service functionality, which includes all aspects of managing the pipeline of data delivery from ADX providers to ADX subscribers. This might sound pretty simple, but believe me, it's not that simple when you consider AWS Data Exchange scale and all various types of data that we support.
Well, I know I can speak for both of us when I say we're really excited to show everyone our content today. So I want to get right to our challenge overview. So this past summer, the AWS Data Exchange team sponsored a hackathon through DevPost, which is the home for online hackathons. The event was completely virtual, but we kept it open to the public and it was a globally available event. This is the landing page of the event you're looking at now, and it details the challenge rules and prizes and the challenges we are asking participants to respond to. Essentially, the AWS Data Exchange Challenge prompted creators to work together to build a solution of their choice that tackles a tough problem in the world today. We had over 1,300 creators tracking and participating in this event, which was awesome. And 30 projects were submitted for consideration to receive over $35,000 in various prizes. Creators needed to demonstrate that their solution uses at least 2 AWS services and at least one of the third-party data products available on AWS Data Exchange. AWS Data Exchange has over 2,300 data products from over 120 data providers, and these providers cover a lot of industries like healthcare, financial services, retail, and many others. Any of these products that are available in our catalog, whether they're free or priced, could be used for this challenge. So as long as the solution and the participants follow the data product subscriptions terms, they were applicable to be used here. Some of those data providers are referenced here. We want to issue a big thank you to these sponsoring companies who contributed extra data that would be applicable for this challenge, making it free of use for our creators. We really appreciate the extra time and effort it took to do so, and this is just a sampling of what's available across all of the projects that were implemented for this challenge. So there were 6 total category prizes that creators could build towards. The 3 main categories we had were data visualization, data analysis, or data and machine learning. Teams could also win additional bonus prizes if they submitted projects that applied to categories like healthcare, financial services, or retail. Depending on their category of eligibility, winners could receive cash prizes of up to $5,000, AWS credits of up to $4,000, as well as follow-up coaching meetings with our technical leadership on the AWS Data Exchange team, and features in some of our upcoming blog posts and events. We also had recognition for large organizations that contributed to our challenge, and 2 honorable mentions as well. So you're going to see a total of 6 demos today that won these various prizes in either one area or several. So let's cover how these solutions were judged and how we selected winners. We had 5 judges from the AWS team review the submissions and vote on category applicability. Thematically, they were watching for competency in machine learning and AI, but also for solutions that could be used to increase productivity or contribute to social good. But technically, Natasha, what were the judges looking for?
Well, in addition to the requirements that you just mentioned about using at least one third-party data set from AWS Data Exchange and at least two AWS services, there was a number of equally weighted judging criteria, and they included quality of the idea, which entails creativity and originality of the idea, then implementation of idea, which is how well the idea was executed by the developers and the extent to which the underlying data was leveraged by the developers. And then there was a potential value, which is the degree to which the solution has the most positive impact for the users and customers. The judging criteria I listed may not have applied to every prize. The candidates for each category were selected from the submissions that were eligible for the prize, and those submissions that earned the highest overall scores based on applicable judging criteria were then selected as the winners of that prize. Make sense?
Yeah, that definitely makes sense. It sounds like several technical competencies were evaluated across these categories. So what impressed you the most about the solutions you saw? Are there any key themes the attendees should watch for when we show these video demos?
I personally was in particularly impressed by the creative ways in which participants integrated AWS Data Exchange datasets with the data from another sources and or combined the data from different AWS Data Exchange providers to create new powerful data solutions. The same can be said about technical aspects of submitted projects where AWS solutions organically integrated with third-party or open source software. Another trend to note is that many submission makers had little or no prior experience with AWS technology according to their own words, but they were able to incorporate multiple AWS services into their solutions, and in some cases they built core functionality of their applications using AWS services.
Very cool. I'm excited to see all these again. So let's get started so we can check out our winning solutions. We have 6 awesome solutions to show you across a variety of winning categories and bonus prizes. Several of these solutions won more than one prize, so I'll intro each solution and their creators, and Natasha will give us some insight on the technical acumen and how they demonstrated the challenge with each of their projects. Then we're going to let the creators speak for themselves and show you the video demos. First up are winning solutions for Best in Data Visualization and Best in Healthcare. This solution is called Access and Equity Health Vulnerability Mapper for COVID-19. 3 students worked on this project as they shared the belief that there is a lack of data-driven and interactive geographic tools that show people the apparent link between socioeconomic disparity and susceptibility to the COVID-19 pandemic in the United States. The Health Vulnerability Mapper presents an easy and engaging way of exploring up-to-date COVID-19 data while directly visualizing the health disparities found in different communities.
The project used daily COVID-19 US counties data from AWS Data Exchange combined with the CDC's Social Vulnerability Index data, along with third-party applications for geolocation mapping and graphs and charts. COVID-19 Vulnerability Mapper application took advantage of the whole suite of AWS technologies. Data was stored in Amazon S3 buckets. Automated processing was handled by AWS CloudWatch and Lambda, and web applications were managed using AWS Elastic Beanstalk. Developers used AWS Cloud9 as their development environment. And this is one of the solutions where the developers, being college freshmen, were new to AWS technologies in general and AWS Data Exchange in particular. This winning solution really showcased how easy it is to discover, subscribe, and use the data from different providers on AWS Data Exchange, and how easy it is to create applications using AWS building blocks. Now, let's see their demo.
This is McKinley County. 90% of its population belongs to a minority group, with 75% being Native American. As of August 2020, its death rate per capita due to COVID-19 is 6th in the entire country. This is Gallic City. Its poverty rate is double the national average, with 3 out of every 10 people considered impoverished by the U.S. Census. It has the second highest COVID death rate per capita. And here is Truesdale County. With a high school dropout rate of 2 in every 10 adults, that's higher than nearly 85% of the United States, first nationwide in the number of cases per person. This trend of socially vulnerable populations being disproportionately affected by COVID-19 is reflected across the U.S. and connects to the larger issues of healthcare access, education, and demographics. That's why we developed Access and Equity, the COVID-19 Health Vulnerability Mapper, a web application that doesn't just tell you about this social disparity, but illustrates it geographically by letting you explore the realities of health inequity yourself. Every county in the U.S. is represented by one of these bars whose height corresponds to your selected COVID statistic, and whose color corresponds to your selected metric of the CDC's Social Vulnerability Index, also known as SVI, with census variables like socioeconomic status, language skills, and minority population. We've also included measurements like high school graduation rate and vehicle ownership, some of which have surprising correlations with COVID-19. By searching for a county, or by simply clicking on one of the bars on the map, you can access information about that county, including its social vulnerability, its current COVID status, the relationship between these two metrics, and how both of these values compare to other U.S. counties. While there's been quite a bit of media attention around social disparity during this pandemic, we saw a lack of real, data-driven, interactive, and geographic tools that show people how and where this issue really plays out on the national stage. To this end, we've implemented several powerful technologies to deliver real-time COVID status along with the latest social vulnerability metrics from the CDC. Our viral statistics are updated daily from AWS Data Exchange, where we've leveraged every data point in the Enigma Daily COVID U.S. Counties database. We use AWS CloudWatch and Lambda to provide automated processing for the 400,000 lines of data we retrieve every day, which we store through S3 and deliver to the user through our Elastic Beanstalk server. The final visualization is then powered through Mapbox and C3.js. For a more intuitive viewing experience, we've used linear scaling to normalize our visualizations. When you search for or select a county, you can explore graphs that highlight the significant relationships between disparity and disease. Here, every county is plotted as a point, with the current county highlighted and the trend line overlaid. Depending on the metrics you select, the scatter plot will change to reflect that. In our analysis, we found a strong correlation amongst SVI and COVID-19, particularly between deaths per capita and minority status. Together, the trend lines and percentile scores of each county serve as indicators of patterns in the data. On select vulnerability measurements, we also include a pie chart, if applicable. Going forward, we're excited to use our tool to partner with nonprofits, governments, and other organizations to spot and solve health inequity. To this end, we're in the works of adding more analytical features, more metrics, and a time series illustrating data over time. Our application presents an easy and engaging way of exploring COVID-19 data while directly visualizing the health disparities found in communities of differing socioeconomic positions. More importantly, we hope that this solution will inspire others to explore, investigate, and take action against health inequity in their own communities. As student activists ourselves, we recognize the severity of these issues and the timeliness of change. We hope this hackathon can act as a platform for us to gain momentum. To help out, we've compiled a repository of resources here on the web app and on our website to address health inequity in communities like McKinley, Truesdale, and countless others. The COVID-19 Health Vulnerability Mapper for the explorer and changemaker in all of us.
Next, we have our winning solutions for Best in Data Analysis and Best Retail Solution. This solution is called GraphMap, created by Horacio Canales. With GraphMap, you can use network science and geolocation visualization to analyze data points' relations on territory. Insights are extracted from the plain text, so the data sets don't necessarily have to be of the same type. An interactive graph visualization, 3D maps, and word clouds are provided to understand insights. GraphMap is also going to be released on the AWS Marketplace soon, so make sure to keep an eye out for it. And it will also include great new functionalities such as doc2vec graphs development and new visuals too, so keep an eye out for that.
GraphMap technical solution fuses network science research with AWS technology and AWS Data Exchange data. The application exports data sets from 3 different AWS Data Exchange providers to Amazon S3 buckets. Front-end triggers queries to Amazon Athena to pull information directly from S3. Then application processes the data with AWS Lambda. It uses network science co-occurrence algorithms to process the description field of each element returned by the Athena query and generate a graph with word relations. The highlights of this submission are running network science algorithms on serverless AWS architecture and consuming datasets from multiple AWS Data Exchange providers. Here is the demo.
Network science lets you understand the whole picture between related data points. This is thanks to the structural properties of a graph dataset. With GraphMap, you can use a network science and geolocation visualization in order to understand insights on territory. Users can query an area from the map, and they will get a result from a dataset stored in AWS S3. The magic happens when the data that you got from this query is processed as a co-occurrence graph. So with this information, we can take advantage of structural properties such as between centrality, modularity, page rank from raw information that is stored in the dataset. And what I mean with the raw information is that you can analyze plain text. And this means that your datasets, they don't have to be from the same category. It means that you can compare datasets from food with datasets from hospitals, from datasets from real estate. It doesn't matter which fields are you analyzing. So you just need plain text. For this application, I use restaurants data. I just got the zip code extracted from another source, the geolocation. Also, I got a menu data, and altogether, it brings me information on territory. But it's not about which restaurants are there. It's about which ingredients they use. Having the information on this manner, I can explore different things, get different insights. For example, I can infer which niche markets are satisfied in some area by knowing, for example, cheese, nachos, or different ingredients. I can know from this point and 100 kilometers which hospitals are there as well, because I don't care what kind of data, I'm just analyzing plain text. I can also, for example, I know that properties that are located near these restaurants, they have a higher value on real estate. So I can also analyze what's the potential price of my home there. But you may be asking how to use GraphMap. What you do is that you select, you move a marker in a place that you're interested in. So you select a radius, in this case, for example, 100 kilometers from this point. And now I just click search. What happened at this point is that I make a query using Amazon Athena to the S3 dataset. And then I run an algorithm that will build the co-occurrence network, and then run algorithms from network X, where I calculate the centrality of the nodes. I use the edges to calculate other properties as modularity. And then I get the result. As you can see, these points are geolocated. And here are the points that are that they have between the centrality, the higher between the centrality. So I can select them, and immediately I can see the relations on the map. As you can see here, I'm using DeckGL to see this 3D visualization, and I see that there are points that are not related to these central points. But then what is interesting is that I can see communities from this plain text analysis. And then what I see is like community 0, general medical, helipad, acute care. Every location will bring you a different insight. For example, here in Florida, we can see more centrality on the ingredients. For example, cheese. And if we see, once again, the communities, here I have more types of hospitals. We can see where are they located the most, and we can see their properties on the hospitals. What kind of properties I can have? Well, hospitals is the very central point that is related to all others, but what if I'm looking for beds from 0 to 25? The main idea that I want to share with GraphMap is that using network science, you can analyze all kind of data because you're just looking for relations. In this case, I just got data from food and hospitals. But what if I can get from other kind of sources, such as real estate at the same time, maybe of population, demographics, and other sources, and put it all together? I'm surprised by the service of AWS Data Exchange. And this thing about data as a service is something impressive. And in many cases, it will solve a lot of problems because it's hard to get the data. And here we just got it.
Now, our winning solution for best in data and machine learning. This solution is called MIA MD, or Medical Intelligence Applied, a two-way health management platform for seniors and caregivers. This solution was submitted by a team of 12 creators who shared the concern that with the onset of COVID-19, the elderly's ability to access usual medical care and mental support have drastically decreased, and the communication with caregivers is impaired. MIA is an application that will help track and manage both physical and mental health conditions for the elderly population. For instance, they implemented a chat box function to ask seniors about mood and emotions, while also providing a means to input health measurements such as vital signs.
Medical Intelligence Applied made use of numerous AWS services and sourced Medicare providers' information from AWS Data Exchange dataset. Amazon Lex and AWS Lambda were used to develop chatbots for daily health check-ins and Medicare provider search. Amazon Athena was utilized for provider search and graph visualization, and Amazon Cognita controlled authentication and access. Android application was developed and deployed using AWS Amplify, and machine learning models were running on Amazon EC2. Machine learning aspects of this application were particularly interesting as they included identification of emotions from facial expressions and speech, identification of body mass index from face images, and detection of falls from phone sensors. Let's now see the demo.
Welcome to MIA, Medical Intelligence Applied. Since the outbreak of COVID-19, the health maintenance of elderly has been drastically impaired. MIA aims to address this problem through creating a two-way app platform that connects the elderly with caregivers. Let's show you how MIA operates.
First, caregivers will sign up for an account with their username, password, email address, and phone number. A confirmation code will be sent to the email to verify their email address. On the home page, caregivers or admins can look at their care recipients' health conditions through the data visualization dashboard. The red notification symbol indicates a warning that requires caregivers to follow up. The caregivers can edit their profile in the profile page. If a caregiver found that the care recipients required follow-up with a particular medical provider, they can search the information of Medicare provider in the living area using the search board. Caregivers can choose to interact with the search board through voice, denoted by a microphone icon, or text, denoted by a pen icon. A copy of the search results will be sent to the email address collected through the chat. Moving on to the patient's interface, seniors will sign up for an account with the help of the caregivers. After logging in, seniors can look at their simplified health report in the form of a data visualization dashboard. As part of the daily health check-in process, a facial image is taken and analyzed using trained machine learning algorithms to monitor emotions, BMI, and more. We have streamlined the user flow and let Mia, our chatbot, to guide seniors through the daily health check-in process. Patients can choose to text or speak to the chatbot. Mia will first ask a few questions regarding their health, such as the blood sugar level and blood pressure, and the seniors can input manually or tell Mia their measurements. For voice inputs, Mia will repeat the measurements to verify. Depending on the needs of the seniors and caregivers, the chatbot can also ask about other matrices, give reminders, and chat with the senior. Here is a chatbot demo with voice interactions.
Welcome to Mia Health Checkup. Today we will ask you a couple of questions about your health. If you are ready, please type or say start. What is your blood pressure systolic? Top number 999/4x. What is your blood pressure diastolic? Bottom number 30/999. What is your sugar level today? What is your body temperature today? Thank you for using services. Your info has been saved.
This overall concludes the prototype for Mia. Thank you for watching.
This next solution won our large organization prize. This solution is called the Claims Subrogation Recovery Prediction and was built from a team of 5 from the company Capgemini. As Capgemini is a consulting and technical services company, they wanted to focus on the impact of the current economic slowdown on the auto insurance sector, and particularly on the rise of uninsured claims. Their solution augments their claims data to uncover important aspects of the uninsured or underinsured claimant using variables such as income levels, weather conditions, and sales preference to build a machine learning model to understand their likelihood to pay the subrogation.
Claims Subrogation Recovery Prediction application used first-party insurance claims data along with AWS Data Exchange datasets from 3 different providers. The data was researched and finalized to augment the solution. For those not very familiar with machine learning, data augmentation in data analysis are techniques used to increase the amount of data and introduce variability in the dataset, which improves the model's quality. So this application used Amazon S3 to ingest and store the data, AWS Glue to join and transform it, Amazon SageMaker to train and run machine learning models, and it deployed the models and UI screens using Amazon Lightsail. In addition to extensive usage of AWS Data Exchange data and AWS services, I would like to highlight the fact that the project team took advantage of Amazon Lightsail, which is the easiest way to get started with AWS, providing everything needed to get the project running in the cloud. Lightsail provides developers compute, storage, and networking capacity and capabilities to deploy and manage applications in the cloud. It includes virtual machine, a managed database, SSD-based storage, data transfer, DNS management, and a static IP, which you all will notice in their presentation.
Hi everyone, this is Manisha. I'm from Capgemini Insight and Data Practice. Thanks for the opportunity to be a part of AWS Data Exchange Hackathon. The theme for our team is Claims Subrogation Recovery Prediction. As the name most likely suggests, the industry is financial services and more precisely auto insurance. The category we chose is data and machine learning. Let me give you some context quickly. What motivated us, or say, what drove us to pursue this use case? Uninsured drivers are a problem for insurance companies, governments, and people like you and me. Since the COVID-19 and after effects of it on economy, unfortunately, unemployment rate at sky-high levels. And so, understandably, many families are faced with difficult economic choices. This has resulted in lot many uninsured or underinsured drivers on the roads. As we can understand, auto insurance companies are affected by this and their claims department are overwhelmed by the quantum of subrogation processing, where the likelihood of recovery is very uncertain. We realized this can be an opportunity to help auto insurance companies to understand the uninsured claimant, who is at fault, of course, to understand his likelihood to pay. With the help of AWS Data Exchange, we augmented our claims data to uncover important aspects of the uninsured or underinsured claimant and thus used those variables such as income levels, weather conditions, and sales preference to build a machine learning model to understand his or her likelihood to pay the subrogation. This can help not only to understand the propensity to pay, but also prioritize the already overwhelmed and understaffed claims department. Let me show you the data we have used. We generated the first party data which has all the typical claims characteristics like age, gender, education, employment, address, etc., and their response in past to subrogation. Augmented the AWS Data Exchange datasets to understand income levels, weather, and behavior. Build the ML model with these datasets. Generated propensity for subrogation recovery. Let's move to our approach for the solution. First of all, we synthetically generated reasonable claims dataset in case of a collision which most likely leads to a subrogation. It had typical claims attributions such as claimant demographics and their response in past to subrogation. We augmented the dataset with Enigma dataset in AWS Data Exchange, having tax returns to understand at a zip code level to extract average tax returns. Also, we ingested Epsilon dataset, that too from AWS Data Exchange, to understand the consumer behavior. Last but not the least, we also sourced weather data to augment our use case study from weather source that is also from AWS Data Exchange. In a nutshell, we ingested third-party data into AWS S3 storage, used AWS Glue to join and transform data, built ML algorithm on AWS SageMaker, finally deployed the model and UI screens using AWS Lightsail. Now let's get to the most important part, that is modeling. We have ingested the data in AWS S3 storage. We used Amazon Glue to perform join and various other ETL processing. Post that, we used AWS SageMaker to train and run our model. We tried different models which are logistic regression, decision trees, and random forests to test the accuracy and recall rates. So after the evaluation, we determined the best performing model for our use case is random forest. The accuracy for the model is 98.57% and recall is 94%. And finally, we deployed UI screens using Python Flask for visualization. To deploy our application on AWS, we have checked in our code in GitHub and we have used AWS Lightsail to deploy our model. Our application is up and running on this mentioned IP address. Based on the data and using machine learning, we created the customer's profile. As we can see here, it has the data profiling page, which has all the data properties and data profiling results along with their custom visualization. Claims data. If we look at it, we can see all the processed claims with their probability of subrogation listed on the right extreme column. Let's look at one of the claims. We can see here all the claims characteristics and mostly importantly the probability of subrogation, which is 75.54%, which is pretty good. On the contrary, we will look into another claim. As we can see there, the probability of subrogation here 0.56%. So this claim has very little likelihood chance of subrogation recovery. Also, we have the factors which has affected the decision. In this case, these are income levels, employment status, coverage, claim notes, claim reason, monthly premium, and loss adjustment expense. So to conclude, model is fully functional and can help auto insurer to prioritize and accurately measure the subrogation likelihood. Finally, the benefits and potential impact of this solution will result in reduction in the effort for claims investigation and loss recovery by 33%. Please let us know your feedback. Again, we are thankful for this opportunity. I just want to thank to my teammates for their contributions. We have great team with Vedant, Shubham, Sumit, Girdhar, and me, Manisha. Have a great day. Thank you so much.
Now, this solution is one of our 2 honorable mentions. Track My COVID was created by a team of 5. Track My COVID is a mobile app which gives you a risk analysis of contracting COVID-19 based on the places you've been to and analyzing the amount of cases recorded and the time spent in each place.
Track My COVID application uses AWS Data Exchange dataset which contains COVID-19 statistics by location. The application classifies different geographic locations into the risk zones based on the population, frequency of COVID-19 cases, their growth rate, and other aspects. Then it integrates geolocation data from the customer feeds and computes customer exposure levels based on the time they spent in the particular zones. The application is hosted on Amazon EC2 instances and uses Amazon S3 along with an open source database to store ADXs and user-generated data. This is another example of how the data obtained from AWS Data Exchange was combined with the data coming from other sources, and in this specific case from the live user feeds, and how the analysis of combined data resulted in much more powerful values that have practical application for the end users. Now on to their demo.
The Track My COVID app. This app is a mobile application to track COVID-19 risk level based on user activity. The app basically works on getting a user's location, classifying them into a zone, and based on the zone, computes the time you spent outside and gives you exposure level to that day. So here are the different zone classifications the app uses. Zone 0 is a home zone. Zone 1 is a green zone. Zone 2 is an orange zone. And Zone 3 is a red zone, ranging from low, mediocre, and high. Now these three, when the user downloads the app, the user sets their home location, and the app understands it as a home zone. So even though your home lies in a Zone 3, when you're at your home, the app reads you as being at a home zone, and the moment you step outside, your zone classification takes place, and the app starts recording how much time you spent outside in a particular zone. Now here's a demonstration of how the app works. Now when you log into the app, you see 6 different features: the map, analysis, statistics, prevention, symptoms, and news. The map gives you a general view of the country that you reside in, and given more time, the map would also give you a zone level view of every zone and of every state and the zone included per county or per street address based on more data from the AWS Data Exchange. Now, here's the analysis portion. The primary function of the app is to first classify you at what zone you reside in. The first graph shows you the exposure levels. This is the zone you're at. The second graph gives you the time calculation that you spent outside. So today I spent 1 hour at home and then 70 minutes outside. Now, based on the 70 minutes you spent outside at a zone level 2, it shows you different types of risks associated. The general risk is 12% of contracting the coronavirus. And if you wore a mask, the risk drops down to 6%. But if you did not wear a mask, the risk goes up to 28%. All statistics based on the zone you're classified at and the time you spent outside. And this third graph gives you an overall exposure, COVID-19 exposure period per day for every 21 days. It keeps resetting as then the last day gets deleted, and it computes the different exposure levels based on the 21 days you spent outside. Every day, the amount of time you spent outside at every zone, it calculates the risk. And here's the last graph, gives you a risk exposure level for the past 21 days. A general risk, a risk with mask, and a risk without mask. And lastly, based on these statistics, there is a reasonable chance for contracting COVID-19. Please take proper precautions. The app gives you a metric based on all the statistics and the places you've been at. How much is your likelihood of getting coronavirus given taking the proper precautions versus given taking the no precautions. And furthermore, the app contains statistics, a prevention page, symptoms, and lastly, news. Finally, the app also contains other features such as Mythbusters, what is COVID-19, and FAQs for finding more information about the virus. Primarily, the app's purpose is the analysis feature, which gives you your daily exposure level and your different risks associated, and overall 21-day exposure period, and the warning that comes here based on your user activity. Hence, track my COVID. Thank you.
And lastly, we have freshAir, also receiving an honorable mention. freshAir was completed by this team of two, Nicole and Siddharth, who wanted to track air pollution across the world and improve visibility on its impact. freshAir visualizes and ranks the air pollution for countries throughout the years to provide analysis and access to visual trends across the world.
Unlike other submissions that use data from different sources, freshAir application is solely based on a single AWS Data Exchange dataset which contains pollutants air emissions data. However, this dataset carries such a rich set of attributes that it alone allowed for multidimensional analysis. With help of Amazon SageMaker notebooks, freshAir creators interpolated the data and built graphs for the amount of different pollutants emitted per country across time. They imported the air emissions data into SageMaker notebooks and wrangled it. Again, for those not very familiar with machine learning, data wrangling means the process of gathering, selecting, and transforming data to answer an analytical question. So the questions were answered, and they made line plots based on the trends. Then they became the foundation of their application. With regards to AWS technology, in addition to SageMaker, the team used AWS Amplify to host the React front-end application. This is another example of the intuitive and easy way to build applications using AWS, as the application team did not have any prior experience with AWS technology. Now let's see their demo.
Hello everyone, this is freshAir for the AWS Data Exchange Challenge. Our mission is to raise awareness about air pollution across the world and provide resources and visuals to analyze the emissions in the past. We believe we can learn from our past data to spark future solutions. The technologies we used included Amazon SageMaker for the plots, React and JavaScript for the front end, Amplify for hosting, and the language Python for the SageMaker code. The dataset we used from AWS Marketplace was OECD Air Emissions by Source provided by Crux Informatics. We'll now show how we hosted our site.
For hosting our visualization project, we have used AWS Amplify. So we have the AWS Amplify here. See, our project is running. So the air pollution visual, and we have successfully built it. And we actually directly used GitHub, and we linked the GitHub. See the GitHub master here, and we have deployed it. So this is the application, and we use Amplify for this. And we have the master branch which is connected to this, and it has almost like the provision build, deploy, and verify has been passed here. And this is the application which is like successfully deployed on the Amplify app, and we have the application here.
Now let's explain the contents of our site. So this is the main page of our site. As the clouds move, we have 2 notes in the beginning as an intro. And then we have our mission and how our tips to reduce air pollution. And finally, we have our map. And on our map, we can change the year 2018 and another year. And yellow means that there's no data from the Crux dataset. And also you can drag the bar on the gradient bar to change the color, and whatever color matches, it highlights with red. And also you can hover over each of the countries and it'll show you some information. And once you click one of the countries, you get to the detail page. So let's go back, and as well there's a label underneath the gradient bar that describes how severe the pollution is depending on the color. Let's go to the ranking. So we ranked by intensity. Stronger intensity is the highest, and then we included the tons and pollutants, and that's for all of the countries. So let's click on one, and for this one, Canada, you can see the different types of pollutants and a graph that we created in SageMaker describing the pollutants effect over the years. Then we have the largest pollutant at the bottom and the total pollutant plot of all of the pollution Canada has brought over the years. As well, you can change the year here, and if there's no data, it won't show that, only the total, and you can go through the years very easily. Now we'll go over how we created the plots.
So we have made time series visualization about how the pollutant is affecting every country and the trends for the past years. So for this, we had to make use of the SageMaker, Amazon SageMaker notebook instance services. So we had the notebook instance here, and we actually created a new instance, and this was created with ML T3 million, and it's on service. So this is the basic notebook, and we have our Python file here, notebook file, and these are the graphs generated. So this is the CSV file, and this is the group dataset which we got from the data exchange. That is for the air emission. So this is the code that is used for the air emission, the graph we completed. So initially we have just wrangled around the data, and we basically found what are the different columns and how the data are. And here we have like around 91,000 data. And we have like different countries, around 40 countries, and multiple pollutants, and we have different variables. We have year from 1990 to 2017 and different units. So basically for our purpose, graph purpose, we have only used tons, and we have completely made the time series graph based on that. So we have wrangled around the data and like generated a few stuff and deleted a few rows. And at the end, we like came up with the data frame in which we have only taken the tons. So what we did is we took up to 40 countries. We for each country how the pollutant carbon monoxide is, like how the time series graph is. So that is what we have used, and we have like 1990 to 2000 up to 2017. So how the graph is changing. So we have like taken everything out of it. So this is the code we used, and this has been done for every pollutant, like sulfur oxide for every 40 countries, nitrogen oxide, and non-methane, volatile organic compounds, and particulates, that is M10 and PM2.5 for each country. So in this way, we could actually generate all the required graphs, and we use this for our application, which we have hosted.
Thank you so much for listening to our presentation.
And with that, congratulations to all of our category winners. And a big thank you to all of our participants. We thoroughly enjoyed reviewing all 30 solutions, and we highly recommend checking them out when you get a chance. They're all available on the DevPost website, which is cited here in the project gallery. We've also provided links here for our AWS Data Exchange newsletter, so you can stay up to date on new data providers and products added to our catalog every month. And we share other news there too, like new feature announcements and upcoming events like this DevPost Challenge and AWS reInvent, which is coming up later in November and December. You can also check out our thematic data pages on macroeconomics and COVID-19 that specifically target you to a themed data subject. Thank you again for joining us for this tech talk on our AWS Data Exchange Hackathon Challenge. Are there any questions we can answer on AWS Data Exchange before we depart?